Hi, we're picking up with what in our book would be called Section 2. In the Pathways to Math Literacy book, it's lesson 1.9. And we are looking at the prep skills. And the first skill is reading data from a list. And the first thing that they talk about is that if we're looking at data that is unorganized, that can be difficult to read. Especially if in this case there's a lot of values. What do we have? 3, 6, 7, 8, 9, 10. So we have 20 different values here. And some of the values might be identical or similar values. And so in this case, rewriting the list in some sort of order is helpful. So this list has been rewritten in order from smallest to largest. If a number is repeated, we write it more than once. So just because there's two 18s doesn't mean we only write 18 down one time. We write it down twice because it occurred twice in the original list. So in looking at this, now we can pick out a little bit of information. So we could say, for instance, that the most common score on this 30-point quiz by these 20 students, I guess it says right there it was 20 students. I didn't have to count it. But it was a 30-point quiz, and the highest score was a perfect score. The lowest was a 12. But the most common score was 27. There was 1, 2, 3, 4 students that scored a 27. And then also 30 was scored by 4 students. So the most common scores are 27 and 30. There were 2 students that scored a 24, 2 that got an 18, 2 that got a 29, but there were no other scores where 4 students got that score other than 27 and 30. And then, as we already mentioned, the lowest score was 12 and the highest was 30. But organizing that data in from lowest to highest, and we could have done it from highest to lowest, it doesn't really matter. As long as it's organized, we're able to pick those patterns out and pick those details out better than in the original list. So with the next slide, they're wanting us, or the next skill, they're wanting us to take this data that we had in this table, or in this list, I should say, it's not even in a table, but that's in this list, and put it into a bar graph. So represent it pictorially with this bar graph. So they've already given us the categories. They have a less than 18, 18 to 20, 21 to 23, 24 to 26, and 27 to 30. So they've given us the numbers up here, but I'm going to actually go through it in the list so that you can see where they got that from. So less than 18, with it being in order, that's pretty easy. And it says less than 18, not less than or equal to. So we're only going to count 12 and 15 in that category. So if we are going to make a bar graph, we're just going to put a bar above less than 18 that goes up to 2. And this really should be, you know, nice and vertical. It's just kind of hard to do on the tablet. Okay. And then next we have 18 to 20. And there's really only 2 data values here that are 18 to 20, and they're both 18 actually. But again, there's 2. So, and I'm going to try to make that bar the same width as the other bar. If we don't do that, and the areas don't look the same, that's a little bit deceiving. If we want the data to represent the same amount, then it should cover the same area on the bar graph, so we should try to make our bar graph, or our bars, the same width. Next we have 21 to 23, and we really only have 1 in that category, and that's a 22. So this was 2, so we're going to try to make it right at halfway. But again, we want to try to keep that width about the same as what we had before, even though the height is different. And so now you can see if I look at these 2 bars, the 18 to 20 and the 21 to 23, it looks like the area of this bar is about half of the area of this bar, which is good representation because there's half as much data in the 21 to 23 as there is in the 18 to 20. And you want it to visually represent what the numbers are showing. Okay, so our next group has a lot more in it. 24 to 26 would be these 4 numbers. And so we're going to come up and again try to keep everything nice and even here, about the same width. And there's our 24 to 26. You don't technically have to color these in, but a lot of times with the bar graphs, they'll color in the bars. And then 27 to 30 is all the way from this 27 all the way up through this 30. So that's all 10 numbers in the bottom row plus the 1 here, so that's 11. So that has to go all the way up to here, halfway between 10 and 12. And again, this is kind of hard on the tablet to draw nice straight lines, but I'll give it a shot. And let me try to make that one just a little bit better. And then we'll color that in, and that's our 27 to 30 range. So you can see with this bar graph that very quickly you could see that over half of the class is in the 27 to 30 range, because we only had a total of 9 up until we got to 27 to 30. And so over half the class got a 27, 28, 29, or 30 on their exam. I have a little bit of an issue with this in the fact that the 27 to 30 has an interval of 27, 28. We'll just list this here. So this would be 27, 28, 29, and 30. Whereas these intervals only included 3 values. So for instance here, 24, 25, and 26, 21, 22, 23, 18, 19, 20. I think if I was going to do this, I think I would try to keep it even. So I think I'd probably do 28 to 30, and then 25 to 27, and so on. I think it would be a little bit more, a little less deceiving. By putting the 27s up here with the 30s, it sort of forced a lot of data up there because 27 was one of the most common scores. So I'm going to actually redo this with that. So in order to do that, I think the easiest thing is just to use what they have. And you could just leave what we had on our notes. That's technically what they wanted us to do. I'm just going to show you what a difference someone making a graph can make in the way that it looks. Okay, so if we go back and we change these to the 3 scores in each interval, that would make this 28 to 30. That would make this stop at 27. So this would be 25 to 27. That would make this one stop at 24. So that would be 22, 23, and 24. This would stop at 21, which would make this 19 to 21. And then our lowest one would be less than 19. So less than 19, 19, 20, and 21, 22, 23, and 24, 25, 26, and 27, 28, 29, and 30. So let's see how that changes the graph, just by making that decision on what our categories down here should be. So less than 19 actually includes 4 data values there. Before we only had 2 in our first category, but now we have 4. And I don't know if less than 18 was picked intentionally. 18 out of 30 is a 60%, so maybe they were trying to show the people that got less than a D. So then we have 19 to 21, which there's nobody in that category. Nobody got between 19 and 21. So that we're just going to leave blank. 22, 23, and 24 are these 3 values. And sometimes when you're doing something like this, they may put just like a little line here just to kind of indicate that it was at 0. It's kind of up to you. Most books or most things will just leave it off, but if you kind of don't want to lose that there was actually supposed to be a bar there, but it had no height. And then 25 to 27 would be 25s, 26s, and 27s, and that would be these 3 in this row. and then these 3 in this row. So that's 6 values that are 25 to 27. And then we have in the 28 to 30 category, we have still 7 values there. Not 11 values like we did before because we put the 27s in this 25 to 27 box, but 28 to 30 is still going to be the highest because there are 6 values there, or 7 values rather. So that's going to come up to 27. It's going to come up to 7. I'm sorry, it's not going to come up to 27. It's going to come up to 7. And so then we have this box. But you notice, I mean, this graph looks quite a bit different than the graph we had before. And so just changing those ranges a little bit changes the way that graph looks and how it's perceived quite a bit. So in looking at a graph, you always want to look at, you know, how the person that drew the graph set it up. Did they set it up reasonably so that it wasn't deceptive or anything like that? Did they keep, did they label things? Are things clear and consistent? And one of the things we talked about in the last lesson is that, you know, when you don't start at 0, that makes things look like they're more dramatic changes than they actually are sometimes. And so we really want to start with the bottom of our graph at 0 whenever possible. So the last thing we need to do for the prep skills are the prep skills questions. And so we're going to look at the data below. It says, are the number of classes missed in one semester by all students in a 5-day-a-week math class. So in other words, one student here missed 2 days, the next student missed 4 days, and so on. So the first thing it says is to arrange the list in order from smallest to largest. So I'm going to go through and I'm going to look for all the zeros. So there's 1, 2, 3, 4, 5 zeros. So I'm going to start with those. 1, 2, 3, 4, 5 zeros. And then there's 1, 2, 3, 4 ones. Then there's, for 2s, there's 1, 2, 3, 4 2s. And then for 3s, we have 1, 2, 3, 4 3s. We have 2 4s, one here and one here. Whoops, I put 2 instead of 4 because we were talking about how many there were. Okay, so we have 2 4s, 4, and then another 4. We have 1 single 5. We have a single 6. I'm kind of trying to keep these lined up. A single 8. A single 10, and a single 18. So now I'm realizing that I don't have these lined up, and I just want to keep that in mind as I go through. I just put all the 2s up here on top, and I actually have 2 more in my top row than I do in my bottom row. So in the top row, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, whereas in the bottom row, I only have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And I don't want to rewrite those, so I'm going to leave that like that. I mean, I did what they asked. I did arrange it from smallest to largest. So, what number of days missed was the most common? Well, there's actually 1 was missed 4 times, 2 was missed 4 times, 3 was missed 4 times, but we can't forget 0. 0 was actually the most common number of days missed. In other words, there were 5 people who had perfect attendance, and that was the most common occurrence among the students. So 0 is actually the most common number of days missed. What were the least and most days missed by anyone? Well, 0 is the least. And then the most would be that one person up here that had 18. So 18 is the most. Draw a bar graph that illustrates how many students missed 0 or 1, 2 to 4, 5 to 8, and more than 8. And again, I'm going to change this because I do not like the way they did this. I think this should be more consistent. So I'm going to say 0 or 1, 2 to 3, 4 to 5, 6 to 7, and then more than 8. So I'm going to add an extra category in here. They had 1, 2, 3, 4 categories, and I'm going to do 0 to 1, 2 to 3, 4 to 5, 6 to 7, and greater than 8. So I'm going to make 5 categories. Again, the reason I'm doing that is I want to keep consistent. I could have also done like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then more than 10 or something like that, or more than 9. But I'll stick with what I originally wrote. Okay, so 0 to 1 day, that was a total of 5, 6, 7, 8, 9 students. So 5, 6, 7, 8, 9, and this would be a lot nicer if I had some sort of a ruler or something, but I don't. So I have 9 students that missed 0 to 1 days. And I should label my graph, of course. I could say attendance for a title, class attendance, and here I could put number days missed. And then over here I could say, it's hard to write sideways, I really should write this sideways, but I'm not going to try, like occurrence. So how many students missed each of those. Now we'll do 2 to 3. And 2 to 3, we've done zeros, we've done the ones. 2 to 3 would be 1, 2, 3, 4, 5, 6, 7, 8 students missed 2 to 3 days. And so I've taken care of the 2s and the 3s, and then we have the 4s and the 5s. There's only 1, 2, 3 of those. So 4 to 5 was only 3. And I should mark these. This is 1, 2, 3, 4, 5, 6, 7, 8. Again, graph paper is a glorious thing, or straight edges and things just kind of hard with the tablet. So 4 to 5 is 3. Then we were going to do 6 to 7. And we only had one student that got 6 or 7. There was one single 6. So we'll mark that. And then we had greater than 8. And greater than, I'm sorry, this should actually be greater than 7. Because the way that I have it written, I actually don't have any place for 8 the way that I have it written, because 8 wouldn't be greater than 8 and it wouldn't be 6 or 7. So this would technically be greater than 7. And so greater than 7 would be these 3 people that had the 8, 9, 10, and 18 absences, so that would be 3 students. And that's kind of open-ended. I mean, it would be better if we didn't have to do the, greater than, but since we have such a wide gap in these last few people, we kind of have to do that. So you can see that most students missed, almost all students missed 5 or less days. We only have one student that missed 6 to 7 and 3 that were greater than 7. So only these are definitely the unusual students in the class, having the 6 to 18 absences, especially the 10 and the 18 are quite a bit away from anybody else. So but the graph helps you kind of visualize that and see that almost all students had 5 or less days that they missed. So at this point I'm going to switch over to the class lesson, and we'll pick up from there.
Here we're given some data about average daily circulation for newspapers, and number 1 asks us to look at that table and determine some preliminary conclusions. Well, looking at that, I think the most obvious thing is that over those 15 or so years, the average circulation definitely seems to be declining. So then we'll flip over to number 2, where we'll use that data to create a scatter plot. So I've chosen a scale that makes sense for each axis, and now I'll plot the points. And then this asks whether we still have the same conclusions we drew before. And I would say yes. Looking at the way that the points are dropping as you move to the right, it does agree that the average circulation is declining. In 3 and 4, we're looking at the definitions of population and sample. So in number 3, in this study of newspaper circulation numbers, what would the population be? Well, that would be the larger group of subjects under study. So we're trying to learn about all newspapers in America. And then in 4, what would a sample be in this case? Well, most likely we don't have circulation numbers on every single newspaper in America. So the sample would be a certain group of those papers that we do have the circulation numbers on that we can use. Here we're looking at the idea of a representative sample. You want your sample to be a nice random group that represents lots of different types of members of the population. So thinking about the newspaper circulation study, which of these do you think would be representative samples? In number 5, daily newspapers in the 10 biggest cities in the United States. Well, that's probably not representative of all newspapers in the US because it's almost certainly going to have the largest circulation and leave out all of those smaller newspapers. In number 6, one newspaper randomly chosen from each of the 50 states. Well, the fact that they are randomly chosen is helpful. That means that we're going to get newspapers from different geographic regions, and because they're being chosen randomly, we'll probably get some large and some small. So this one will probably be representative. In 7, all newspapers affiliated with a national media conglomerate. This one's a little harder to be sure on. It's very likely that newspapers, both large and small, would be affiliated with the conglomerate, and because we're only interested in circulation numbers, we don't have to worry so much about that conglomerate having a particular political slant. However, we really just don't have enough information here to know whether that would be representative of all newspapers. And in general, choosing all that are affiliated with one group is probably a bad idea. And in 8, all newspapers in the country are listed alphabetically and every 10th one is chosen. While this technically is not considered to be random because it's very systematic, it would most likely be representative. We'd probably get a good mix of a lot of different kinds of newspapers. Here we're looking at the results from a survey of adults who read newspapers, and it asked them in what format they read their newspapers. Number 9 wants us to think about whether this would be best represented with a scatter plot, pie chart, or bar graph. And a pie chart's probably the best option here because the way the survey was written, each person would only pick one of these answers. That works really well with a pie chart. You can convert those to percentages and you're comparing parts of a whole. In 10, how can you tell that this data came from a sample rather than a population? Well, think about it for a second. If you're trying to learn about all adults who read newspapers, it would be very impractical to get responses from every single adult in the entire country who reads a newspaper. So it's very likely that these responses just came from a portion of that population, which would be a sample. In 11, it's a relatively common belief that print newspapers are becoming a thing of the past. Do you think the data supports that idea? Well, looking back at those responses, 51% only read their newspapers in print, and some others combine print with other formats. So it does not seem like print is becoming a thing of the past. Here we're looking at frequency distributions, specifically categorical frequency distributions, which is a nice way to organize data. In number 1, we have responses from 28 college students about the source they are most likely to get news from. What should the categories be? Well, looking at this, we've got several repeats of different sources. Those would make the most sense for the categories. We can tally how many are in each. And then in number 2, we're going to go through those responses and tally up how many students chose each. And then for the frequency column, we'll convert each of those to actual numbers. You wouldn't have to do the tally mark step, but some people do find it helpful for organizing their counts. In number 3, we're going to use that distribution to write some conclusions on the sources for typical college students. Well, looking at these responses, internet was way ahead of everything else. However, with only 28 responses, that's really not enough data for reliable conclusions about all college students. In number 4, we're going to use the frequency distribution that we created to draw 2 different bar graphs. So the one on the left, the scale on the vertical axis starts at 0. Let's do that one first. And then the one on the right, someone decided to start the vertical axis just a little bit less than the lowest frequency. So this one starts at 3. Let's see what that looks like. And you can see that looks quite a bit different. So in number 5, which one would you choose if you wanted to exaggerate the difference between the students who chose print media versus radio? Well, looking at this, in the first graph, print media and radio look very close together because they were. But in the second graph, radio looks twice as tall as print media because you've cut off the bottom of the graph and zoomed in on the top. So if you were trying to make radio look really good, you would choose the second one. Here we have some data on visitors to websites of different newspapers. And number 6 wants you to look at this data and think about why a categorical frequency distribution would be a bad idea. Well, looking through these values, there are very few repeats, which means almost every newspaper's number would be its own category. That would not be very helpful. So instead, we'll use something called a grouped frequency distribution, where we create categories of different ranges of values. In this case, we call the categories classes, and they've gone ahead and filled in some evenly spaced classes for us to use. So we're going to go through that data table and count up with tally marks each newspaper that had a number of visitors within each class. And in these cases, the tally marks really do help us get more accurate counts. And we'll also use that to fill in the frequencies. Now we're going to use this frequency distribution to draw a histogram. In number 8, a histogram is a special kind of bar graph. Because we have numerical values, we can actually mark the horizontal axis off as an x-axis. And so the bars will actually touch at the edges. And then in number 9, we're going to use our frequency distribution and histogram to write down at least 3 observations. I think we can see it pretty well by looking at the histogram. The vast majority of sites experienced between 5 and 15,000 unique visitors. And then 15 to 25, 25 to 35, and 45 to 55,000 were pretty even. And none of the sites had between 35 and 45,000. In number 10, we're going to look back at the original data to see if any of the data values are right on one of these borders, 25, 35, or 45,000. And looking back, it looks like none of them are exactly on a border. Well, number 11 says, what if one was on a border? What if this website had 25,000 visitors? Looking at the histogram, which group would it go in? Well, looking at the histogram, it's hard to tell because there's a border right at 25 and we don't know whether to include those in the lower group or the upper group. So 12 says, what about in the frequency distribution? Well, our frequency distribution was much more specific. You can see here that 25,000 would not go in the 15 to 24.9 class. It would go in the 25 to 34.9 class. Here we're given some data on market penetration for the top 25 newspapers in America. In 13, if you were to build a grouped frequency distribution, what classes would you choose? How would you break up these values? And you could make some different choices, but I think just counting by tens would be too big of classes. I would probably break them up into fives, and it looks like we do have a 49. That's our lowest, so I'd probably have a chunk from 45 to 49, and then 50 to 54, and 55 to 59, and 60 to 64, and so on. And the highest one is 75, so we'd need to get up to 75 to 79. Now in 14, if we're going to make a stem and leaf plot, what would you pick for the stems and the leaves? Well, because we have all two-digit numbers, it works pretty well to use the first digit for the stems and the second digit for the leaves. In 15, do you think the data in this table come from a representative sample of all American newspapers? Well, probably not, because it told us that these were the top 25 in the country, and so that would not be representative of all of the newspapers. In 16, thinking forward to our stem and leaf plot, let's list all of the first digits. Well, it looks like we have things in the 50s, 60s, and then there's that 49, and then that 75. So we have 4, 5, 6, and 7. So in 17, they have us go ahead and write those stems in the stem and leaf plot that is in 18. So we'll go down there and 4, 5, 6, and 7 under the stems. Then in 18, they want us to go through all of the data values and fill in all of the leaves. So we had a 49, and then we had a bunch of 50s. So I'll go ahead and write all those down as I see them in the table. And then I'll do the same for the 60s. And then we had 75, so that would be in the 7 row of 5. So we have 49, and then in the 50s we have 56, 51, 53, and so on. In the 60s, 62, 64, 68, and so on, and then 75. Now in number 19, we're going to rewrite this stem and leaf plot with all of the leaves in the 5 and 6 row rearranged to be in order. And so in 19, that's what the final stem and leaf plot would look like. In 20, we're going to use that to write some observations. So first I notice that all of the market penetration percentages for these top 25 newspapers are between 49 and 75%. I also notice that by far the majority of them are in the 50s. And I also noticed that there was kind of a gap between the highest and the next one down, because most of these are pretty close together when you look through them. And then there's a little bit of a gap from 64 to 68, but then there's this fairly large gap from 68 to 75. After looking at all of these different things in this lesson, we're asked to compare grouped frequency distributions, so those are the ones that are grouping numerical data into classes, histograms, and stem and leaf plots. So how are they similar? Well, they're similar because they all organize data for you by grouping them into numerical ranges. Now, which one you think makes it easier to analyze a set of data kind of depends on how much detail you need. A histogram is probably the easiest in terms of comparing the different classes at a quick glance. However, if you need a little bit more detail, it might be worth it to look at the frequency distribution or a stem and leaf plot. Here we're looking at a study where they stopped 30 people at a subway station and asked what their most common source of news was. In number 1, do you think this would be a representative sample for all New Yorkers? Well, probably not. First of all, it's only 30 people. That's really not a big enough sample size. And second of all, they're all from the same location, and that is not a good way to get a good mix of people. In number 2, here are a list of their responses, and we're supposed to construct a frequency distribution. So first, we need to list all of the categories. So we have T's for the New York Times, D for daily news, P for post, and O for other. Now we need to go ahead and count how many gave each response. So for the New York Times, it looks like there are 4 T's. For the daily news, we're counting up the D's, and it looks like there are 7 of those. For post, we're counting up the P's, and there are 8 of those. And for other, we're counting up the O's, and there are 11 of those. In 3, what single source do you think was the most common source of news? Well, that would be the post. Of the 3 that were listed separately, it had the most. And if there were another source in the other category that had 8 or more, it probably would have been listed out separately. Here we're using this data on overall advertising revenue for the American newspaper industry. These are all in billions of dollars, inflation adjusted to 2015. So in question 4, we're asked to build a grouped frequency distribution. They tell us what the classes should be. They should start at 10 and go from 10 to 19.9 and so on. Let's check and see how high we need to get. It looks like we have values in the 60s but none in the 70s. So we'll list our classes out. We'll start with 10 to 19.9. That means the next one will pick up at 20 and go to 29.9, and we'll do that all the way up through the 60s. And then we'll need to go back through the table and count how many years fall into each of those ranges. And so I did that, and I got the frequencies 2, 4, 1, 5, 17, and 7. So then in 5, which class contains the most number of values? Well, that's the 50 to 59.9 class with 17 as its frequency. And what that means is that the most common annual advertising revenue during the years that we were looking at was the $50 to $59.9 billion range. So then in 6, we're going to draw a histogram using our frequency distribution. First, we need to label the axes. So the horizontal axis will be the ad revenue classes. And even though my classes started at 10, I'm going to go ahead and start this at 0 to show that there weren't any between 0 and 10. Then on the vertical axis, we'll have how many years fell into that class. And on the vertical axis, it is pretty important to start at 0. Now I'll go ahead and fill in the heights of the bars based on the numbers in our frequency distribution. So in the 10 to 19.9 class, the frequency was 2, and the next class had 4. The next one only had 1. The next one had 5. Then the 50 to 59.9 class was our highest with a frequency of 17. And then the last class, 60 to 69.9, had 7. Here we have a stem and leaf plot that represents the number of daily newspapers in each of the 50 states plus the District of Columbia. So in question 7, using this stem and leaf plot, how many states had 656 newspapers? Well, none. Looking at this, the leaves are the ones digit, and so the stem for that would have to be 65, and we don't have any stems that are 65. In 8, how many states had 25 newspapers? So that would be with the stem of 2, and there are 3 5s in the 20s row. So those are all 25s. In 9, how many states had less than 30 newspapers? Well, 30 would be the lowest in the 3 row, so everything less than 30 would be the other 3 rows above it. So we'll count all of those leaves to see how many there were. and there are 28 of them. Now we want to look at how many states had more than 100. Well, there's a 90, and then the next one up is 118, so it would be that and everything larger. Looks like there were only 4. Remember, those zeros don't mean that there weren't any. That means that number has a 0 in the ones place. And then in 10, what are the largest and smallest numbers of newspapers in any state? Well, the largest would be the one at the very bottom, 230, and the smallest would be the very first one, which was 03, so just 3. Here we have some data about individually paid print circulations in thousands for select newspapers in the U.S. And in number 11, we're asked to build a stem and leaf plot, and we're told at the bottom with the key that the leaves should be the ones digits, so we need the stems to be the 1 or 2 digits before that. And so looking at this, we have everything from 90 up to 528, so we're actually going to have a lot of stems. We're going to have stems from 9 to 52. And then we can go through and fill in the leaves for each. So we have a 90, that would be 9 and then 0. And we have a 92, so that'd be 9 and then 2. And we have a 94, so 9 and then 4. We don't have any hundreds, so we don't have anything in the 10 row. We do have 110, so that would be 110. And we have 114, so that'd be 114, and we'll continue on like this. And you can see we have this huge gap between 330 and 528. So number 12, how useful do you think the stem and leaf plot is in this case? Well, looking back at this, not only did it go on forever, there were so many stems, but it's incredibly spread out. There's not a lot of useful information here other than the fact that most of the values were between 90 and 169, but really a frequency distribution probably would have been a better choice for this data. In 13, based on everything you've seen in this lesson, how would you assess the claim that the American newspaper industry is dying? Well, this is an opinion question, but to me, looking back at the data, I think that it is probably not true. Most of the data sets show some signs of decline over time, but they do still show that the industry seems to be alive and well. And then in 14, of the 3 methods we've used to represent data, frequency distributions, histograms, and stem and leaf plots, which in your opinion is easiest to interpret? This is of course an opinion question. My opinion would be histograms. To me, that visual display makes it much easier to compare classes very quickly at a glance.